right, so today we're going to look at our second to last section on vectors, which is 8.5 part 3. In your packet, it is 5.5. Okay? If you want to look in the book, that's where you would find it, 8.5 part 3. Okay, this section is on what's called the dot product. Okay, so we're going to be looking at multiplication and some of the applications of things we can do by multiplying vectors together. All right, so suppose we have these two vectors, okay? Two vectors written in unit vector form. Okay. So all the coefficients, a1, a2, b1, and b2, those are all just numbers. Okay, so a1i plus b1j, those are the components for vector v. And for vector w, we have a2i plus b2j. Okay, the dot product, very easy operation to do with vectors. And it gives us a way to take a vector and multiply it by a vector. Okay, we're not scaling it. We're not doing a number times a vector. Now we're doing a vector times a vector. Okay, and after we do that, I want you to look at the type of answer that I get. Do I get a number or do I get a vector? Okay, well, here's the dot product. So the dot product, v, you pronounce it v dot w. Okay, and you do have to say dot. I'll tell you why in a minute. So v dot w equals a1 times a2 plus b1 times b2. So keeping in mind that a1, a2, b1, and b2 are all numbers, what kind of answer do you think the dot product would be? It's a number. Yeah, it's not a vector. It's just a number. Okay, we'll talk about later what we can do with that number. Okay, so the reason you have to pronounce it v dot w is because there's two ways to multiply vectors together. There's what's called a dot product, and there's also a cross product. Okay, we're going to do cross product tomorrow. I can't show you cross product today because cross product doesn't exist two-dimensionally. Cross product only works in 3D. Okay? So if you were just to say to somebody, multiply the two vectors together, that's pretty vague. They wouldn't know what to do. You have to say multiply with a dot product or with a cross product. If it's two-dimensional, then it's obvious it's a dot product because cross product doesn't exist. All right. So again, you just pronounce it v dot w. Right, so here's two vectors. I want to find the dot product. Okay, v dot w. So based on that formula up above, anyone think they can tell me first two things we're going to multiply together? 2 times 5. Okay, what's going to come after that? Plus. Negative 3 times 3. Okay. 2 times 5 is 10. Negative 3 times 3 is negative 9. So the dot product here is 1. Any questions on v dot w? All right, let's try w dot v. Okay, what's going to change when I do out the calculation here? So what's going to be first? 5 times 2 plus 3 times negative 3. Right, so now we're doing the w first and then the v. 5 times 2, 3 times negative 3. So what's the dot product of w times v? 1. So what does that mean? It's commutative. Okay, the dot product, I don't know if I write that. Yes, I do. Dot product is commutative. Now, when we look at the cross product, it is not. Right? So when we get to cross product, that might be the first time you've ever seen something where if you change the order you multiply, you get a different answer. Has anybody ever seen that before? Usually you don't. Right? 3 times 2, 2 times 3, you can switch the order and you're okay. But when we get to cross product, it's not going to work if it's not commutative. Right, let's try v dot v. So I'm going to scroll back up. How would I do v dotted with itself? 2 times 2 plus negative 3 times negative 3. So 2 times 2 plus negative 3 times negative 3. And that would be 13. Okay, and let's try w dot w. Okay, what would that be? 5 times 5 plus 3 times 3, or 9. 5 times 5 plus 3 times 3, 25 and 9, 34. Does anybody recognize what dotting a vector with itself is similar to doing?
Square.
And when did we square these numbers? When we did what operation? Why would we? When we want to find magnitude, right? So dotting a vector with itself is almost like finding a magnitude, except you're not taking a what? You're not doing the square root. Okay? So the length of v would actually be the square root of 13. Length of w would be the square root of 34. Okay? Right? So when you dot a vector with itself, you don't get its magnitude because you didn't take the square root. You get its magnitude squared. Or if you rewrote it, the square root of the dot product with a vector with itself equals the magnitude. Okay, this is going to come in handy when we go through a proof of where something comes from in a little bit. So if you have the magnitude of something squared, it's the same as just dotting the vector with itself. Okay, and we just showed that with 2 examples. Okay, any questions on that? All right. This time I want to dot these 2 vectors. They're in algebraic form. That's what we called it. What would you get when you do the dot product here?
0.
0 the number or 0 the vector?
0 the number.
0 the number, yes. Okay, because you do 2 times 0 plus 6 times 0. I can write it out. And again, dot product always gives you a number, so you would not write 0 the vector. What if you subtracted 2 vectors that were opposites? What would that answer be? 0 the vector. Okay? If you subtract or add vectors, that's when the answer is a vector. When you multiply vectors, the answer is a number. Right? So I could ask you, could you do something like this? 3 dotted with the vector 4, 2. No, that's impossible. You can't do a dot product with a number and a vector. Okay? You could do a scalar, okay? But if you're going to do a scalar, you don't put the dot. All right? So we talk about in Algebra 1, you can write multiplication different ways. Well, we have to be very specific with vectors. These are totally different problems. One's impossible to do, and one is just a scalar product. Okay, any questions on that? Okay. It turns out that the dot product is distributive. Okay, we're not going to go through a proof of this, but you can do u dot v plus u dot w. In fact, you can even FOIL with it. Okay, just remember that as you multiply out, it's dot products. Okay. All right, now we're going to take that idea, the fact that we can distribute. We're going to use some of the concepts we came up earlier, like dotting a vector with itself is the magnitude squared. And we're going to use that to figure out a formula for the angle between 2 vectors. All right, so we'll come back to writing down this formula in a little bit. First, we're going to go through a proof of where the formula comes from. And I think once we go through the proof, then you'll really see how much work this very simple formula we're about to have saves us. Okay? Let's start with this picture. Okay, in that picture, I've labeled two vectors, okay, u and v. And my goal is to find theta. Okay, I want to figure out the angle between u and v. Well, what shape could we make out of that? Yeah, we could make a triangle out of it. Right, so we'll just draw our line. Like that. And I want to know what that vector in black is. It's actually some kind of combination of u and v. Do you think it's u plus v? All right, it is u minus v. If you try u plus v, okay, what's in green is u plus v. Okay, that's not u plus v. Okay, if you put these back and you take u, and then let's flip it. Left, right, flip it up, down. Now put that on the end. You'll see that what I drew, I'll put that back. What I drew in black is really u minus v. It's u plus the opposite of v. Okay, that's the first step. Okay, just to recognize that this is u minus v. To avoid confusion, I'm not going to put arrows over everything, because I think it's just going to add lots of symbols and it's going to look confusing. Okay, but u and v are vectors. Okay. Now, if you knew all three sides here, how could you find that angle? The law of cosines. Right? So what I'm going to do is set up the law of cosines with these symbols. Now, when you're doing the law of cosines, you're dealing with the length of the sides. So what do I have to do to each one of these vectors to focus on their length? Right, so we're going to put magnitude. Okay, we're not going to write u and v. We're going to put magnitude of u, magnitude of v. All right, so let's start our law of cosines. All right, law of cosines says one side squared equals the sum of the other two squared minus, does anybody remember what comes next? Before the cosine.
It's negative
2.
minus 2 uv.
Yep, just we're going to put magnitude u, magnitude v.
And then it's cosine of theta.
Yeah, theta, whatever your angle is. Okay, any questions on that? All right, so now we're going to figure out basically two different formulas, okay, and we're going to set them equal. So for now, I'm just going to put a box around that, and we're going to come back to that later. Okay, I'm going to take a look at just this left-hand side. Magnitude of u minus v squared. What's a different way I can write this using this idea? Okay. Somehow I want to replace magnitude of something squared with a dot product. Okay. Let's go back and look at what we have. So what dot product could I put right here?
The square you got.
Right, let's go back and look at it again. The magnitude of this squared is this dot this. So what is it? Can you be more specific how you say it? Yes. U minus v dotted with itself. Okay? So the magnitude of this squared is this dot with this. Whatever you have inside the bars, that's what you put here, dotted with itself. All right, so let's go back and look at it. Whatever we have here inside the bars, we're going to put it dotted with itself. So u minus v dotted with u minus v. Okay, this is an alternate way to write the magnitude of u minus v squared, not using the law of cosines. Right? So what we put in the box in red, we're going to come back to that. We're not using that right now. We're using something else. All right. Now, how would we do this out?
Foil.
Yeah, basically foil it. So if you foil it, can somebody tell me what you'd have?
U squared minus 2uv.
Not u squared.
Oh.
Yeah, u dot u, which we can change to something, but it's not u squared.
Yep.
Okay, but we will change that in a second. So let's just leave it as u dot u. Yep.
Minus
Minus
u
u dot v
minus u dot v.
minus another u dot v. So how many of those do we have?
2 minus 2.
So we have minus 2, which is good. We'll see where that's going to maybe come up in a little bit. Minus 2 u dot v. And what about negative v dot negative v?
V dot v.
Yeah, just a positive v dot v. Okay, any questions on that? So now that is our second step, second equation. All right, so now we got equation 1 and equation 2. What's in the red box? Both of them are equal to magnitude u minus v squared. So what does that mean about these red boxes?
They're equal to each other.
Yeah, so let's set them equal to each other, and then we're going to start getting a lot of things that cancel out. So we have u dot u minus 2 u dot v plus v dot v, and now equals everything else. Magnitude u squared, magnitude v squared, minus 2 magnitude u, magnitude v, cosine theta. Now, so I don't have to rewrite the whole thing. I'm just going to put a line through something and rewrite it. What is u dot u?
Magnitude v squared.
Yeah, using the formula we had earlier, if you dot a vector with itself, that's the magnitude of the vector squared. So how about v dot v?
Magnitude v squared.
That's just the magnitude of v squared. Right, when you have the same thing on both sides of an equation, it cancels out. If you subtract the magnitude of v squared from both sides, that would drop off. Okay, what else could you subtract?
Magnitude u squared.
Not yet. Yeah.
The magnitude of u squared.
Okay, subtract that from both sides. And now just write down what we have left. Negative 2 u dot v equals negative 2, which actually we could have canceled the negative 2 as well. Cosine theta. And let's get the cosine theta by itself. So how would I move everything away from the cosine theta? Yep, divide by yep, negative 2, magnitude u, magnitude v. Negative 2, magnitude u, magnitude v. So what am I left with on the left now? Okay, where, no, not quite. I don't have magnitude u You can't dot a magnitude with a magnitude. So what do I have on the left-hand side now?
U dot.
It's right there. I'm just basically looking for pronunciation on it. So what we have on the left, it's
U dot V divided by magnitude U.
so U dot V, yeah. Divided by, how'd you say the bottom?
Magnitude U, magnitude V.
Magnitude U, magnitude V. You can say times on the bottom, that's fine, because you're multiplying those two. But in the top, you can't say times. And all of that is equal to what? Cosine theta. Okay, so there is our very simple formula to find the angle between two vectors. Okay, it started out kind of complicated, but it's extremely simple. All you need is the dot product and the length of each vector. Okay, and that's equal to the cosine. Okay, so the denominator is the length of u times the length of v, and the numerator is just the dot product. So really, this formula comes from the law of cosines, okay, but it saves us from doing the law of cosines every time. Okay, so let's try finding the angle between these two vectors. Okay, what are the three things I need to find in order to get the angle between these two vectors?
Find the magnitude of u and v.
Magnitude of u and v. And what else? Yep.
Product of U and V.
What kind of product?
Like the dot product.
Yes, we need the dot product. Right? And that's it. Just find those three things. So all things we've done before. Let's start with the dot product. The first part is 4 times 2.
8.
Plus
Negative 15.
negative 15.
Negative 7.
So my dot product is negative 7. Okay, magnitude of u. All right, so it's going to be the square root of, what's my first number?
16.
16. And 9.
Which is 5.
Yep. Gives me the square root of 25 or 5. So magnitude u. And lastly, magnitude v. My first number?
4.
Second number? 25. Square root 29. Right, so fill that into the formula. And we get cosine theta equals
Negative 7 over 5.
over 5 root 29. And now I don't want the cosine, I want theta.
Cosine of
Okay. Take the inverse cosine of what's on the left, and what's on the right, and that's our inverse cosine of negative 7 over 5 root 29. And for this, you can stick with degrees. Okay. So inverse cosine is at negative 7 and 5 root 29. All right, so I typed in something wrong, obviously. All right, put your denominator in parentheses. That's what I did wrong. Okay, if you don't put that in parentheses, it's not going to follow the correct order of operations the way we want it. Okay, now that'll be fine. 105.07. Okay, that's the angle between the two vectors. Okay, any questions on that? So, not the quickest formula to derive, but very easy formula to use. Just have to find three things, plug them in, and do an inverse cosine. All right. Sometimes two vectors, the angle between them is something special. Okay? And one of the cases we're going to study is when the two vectors are perpendicular. Okay? If they're perpendicular vectors, we have a special word for that. We call them orthogonal. Okay, so if two vectors are orthogonal, that just means they're perpendicular. And that would mean the angle between them is what? 90. All right? Let's think about that for a second. If they're perpendicular, the angle between them, what did you just say it would be? Nick? 90. Okay? Let me make up something where I already know the angle. Okay, let's just say we had something, let's go like this. Cosine of 90 equals, let's say we didn't know the other side. Okay, there's a dot product on the top and a product of magnitudes on the bottom. What's the cosine of 90? Zero. So if your vectors are perpendicular, okay, the angle between them is 90. So if the cosine of 90 is 0, what does this imply? That the dot product is 0. Perfect. Okay, so that's our shortcut. If the dot product between two vectors is 0, that's a shortcut to figuring out they are perpendicular. Because the only way that that fraction could equal 0 is if the top is 0. Bless you. And what's in the top? Your dot product. All right, so let's figure out if these two vectors are perpendicular. Okay, what's the coefficient of I in vector W? 1. So what's 2 times 1? 2 plus 2. Those are not perpendicular. Great. So any questions on why we got a dot product here of 4? Okay. So not perpendicular. Okay. So what's the question? Are these perpendicular? No. What could you change in this problem to make them perpendicular? Put a negative where?
Any one of them.
Any one of them. Yeah, make any coefficient negative, and then you'd have a negative 2 times a positive 1. That would give you negative 2, positive 2. Just put a negative in somewhere, and you'd make them perpendicular. Okay? All right, let's try looking at another case. Okay, what else can happen between two vectors is they could be parallel. What do you think the angle would be between vectors if they're parallel? Perpendicular is 90. No, Jean-Paul, what do you think? There's going to be some angle. Okay, 180 is an option. And there's also one other option, which is the same as 0. Okay, so if you have vectors that are parallel, you guys got them, that's good. Angle is 0 or 180. Okay, let's think about that for a second. So 0 or cosine 180. What's the cosine of 0? 1. And 180 is negative 1. So, what does this imply?
That the dot product and the bottom are the same.
Yeah, the only way you can ever get a fraction to come out to 1 is if the numerator and denominator are the same. So it's not really much of a shortcut, but if the numerator and denominator come out the same, then they are parallel. Or they don't just have to come out the same, they could come out, what else?
One that's negative of the other.
And those are called opposites. Okay, they either have to come out the same or opposites. So we still have to find both of them. It's not like the shortcut last time where you could stop with the dot product. You do have to find the bottom two. All right, so let's determine if these two vectors are parallel. Does everybody have what the angle is to be parallel? Okay. Let's start with my dot product. John, it's 4 times 20? 80? And John, negative 5 times negative 25? 125. So my dot product is 205. Okay. Anybody tell me what how I'm going to find the magnitude of V?
16 plus 25.
Which is the square root of 41. And how about magnitude of W?
400 plus 625.
400 plus 625. Square root of 1,025.
Factor out of 5.
Yeah, or you can just use your calculator. That's fine. But yeah, you could try and reduce these and figure it out. If it was a non-calculator question, like on a test, you'd have to be clever about it. But in here, you can use your calculator. Let's just multiply the magnitudes together. Okay, all they're asking, are they parallel? If they're not parallel, they're not asking for the angle. So just check and see. The top and bottom come out the same, or they come out opposites. Right, so square root of 41 times square root 1,025. What am I hoping to get? 205 or negative 205, but obviously this is a positive times a positive, so it's positive. And now the numerator and denominator are the same. So we get 1, they are parallel. So yes, V and W are parallel. Okay, if that trick doesn't make sense at this point, you could plug it into the formula, but you would get this. The top and bottom came out the same. Take the inverse cosine of 1, that's 0. An angle of 0 means parallel. Okay, any question on that? All right. All right, so our airplane problem. All right, so this, I think, is in your packet if you just want to look there. Let's see. Okay, I think this is 500 miles per hour south. Is that this problem? Yep. 80 miles per hour northeast. Yep. Okay, it's example 3 in your packet. So if you don't want to copy it down, just look there. Right, so our plane is maintaining an airspeed 500 miles per hour south. And the jet stream is blowing in a northeast direction at 80 miles an hour. I want to find the actual speed and direction of the aircraft relative to the ground. Right? So there's a difference between speed relative to the ground and speed in the air. Does anybody know the difference between the two? Okay, a simple way to explain it is, let's say you were driving down the highway, okay, and there's no wind at all. Okay, wind isn't blowing today. If you're going 50 miles an hour, and someone on the side of the road with a radar gun points it at your car, how fast would it say you're going? 50. If you stick your hand out the window, how fast would the air be hitting your hand? 50. Right? Going 50, there's no wind. Stick out your hand out the window, you're going to feel like your air is hitting your hand at 50 miles an hour. Right, now let's say you're driving into a wind 20 miles per hour blowing at the car, and your speedometer says 50. Okay, somebody with a radar on the side of the road pointed at your car. How fast are you going?
70.
50.
Your speedometer says 50.
30. You're going 50 still.
Your speedometer says 50. Your car is moving at 50, right? Regardless of the direction of the wind. Okay? Any question on that? Now, if you put your hand out the window,
Now you're hitting 7.
now it's going to feel like the air is hitting your hand at 70 because you have the 50 miles per hour speed of the car plus the wind is blowing at you at 20. So it's going to feel like it's hitting your hand at 70. Okay? That's the difference between airspeed and ground speed. Airspeed is how fast is the wind moving over the object. Ground speed is if somebody pointed a radar gun at the plane from the ground, how fast is the plane moving. So wind airspeed and ground speed aren't the same. Okay? All right. So in this problem, what I want to do is try to draw it out. Okay, let's first draw the airspeed of the plane. Okay, what direction is the plane flying in?
South.
South. And how fast? 500 miles an hour. All right, so let's represent south. Okay, like that. Let's make that a bit bigger. And let's make that red. And let's make it an arrow. Right, so that's the vector for the plane. Let's call that v sub p. Now I want to draw a vector for the jet stream. What direction is the jet stream blowing? Yeah. It's blowing exactly northeast. So if this is east, this is north, it's exactly halfway between north and east. So what would the angle be? Yeah, it would be a 45-degree angle. If it wasn't blowing northeast, they'd have to give you an angle and say the wind is blowing at a 20-degree angle to east, okay, or something like that. Right, so here's your vector for the wind. Okay, let's call that v sub w. And let's make it an arrow. So is the jet stream going to help the plane, or is the plane fighting against it?
Fighting.
Yeah, the plane is trying to fly south. The jet stream is blowing up and to the right. Okay, so this is going to slow the plane down. And if I want to find out where it's really going to go, put that there. That's the actual direction the plane is going to go. Okay, I'm going to put the wind back where I had it. I just wanted to show you. Let's make it that color. Those look too much the same. That looks different. Okay. Let's call that v sub a. That's the actual velocity vector for the plane. So it's going to slow the plane down a little bit, and it's going to blow it off course. All right, now what we have to do is represent v sub p and v sub w as velocity vectors. Okay, and then, well, let's see what we do from there. Okay, let's start with v sub p. Okay, so this is where we're going to use this formula. Magnitude v cosine theta plus, you know what, let's do it. It's going to be the I component plus sine theta. That's the j component. Okay. What's the magnitude of the vector for the plane? 500. Don't worry about minus. That's going to be taken into account with the angle. Okay. So it's 500. And that's 270. Yep. Plus i's. Put the I right next to it. plus sine 270j. Now it's flying south. There's no horizontal component to the velocity vector for the plane, so I'm hoping one of these comes out to what? 0. Okay, let's do cosine 270. If you know it, that's fine. If not, just check it. 0. There's no horizontal component to this. How about sine 270? Not 1. It's -1, and it should be, because now you have 500 times -1 j, so it's -500j. That's the velocity vector for the plane. Let's find the velocity vector for the wind. Okay. What's the speed the wind is blowing at? 80. And what's the angle it's blowing at? Yep, it's always the angle with east, okay, or our positive x-axis. Cosine 45 I sine 45 j. Does anybody remember the cosine of 45? Just the 3 numbers? 0.707. So I need to do 80 times 0.707. 56.56 I. And since it's blowing northeast, it should be exactly the same horizontal and vertical components. But if you're not sure, you can check it. The sine of 45 is also 0.707. And if you multiply by 80, you get 56 point, I guess we should round up to 56.57. But in this case, 56.56 would have been okay. And that's your velocity vector for the wind. Now, how would you find the actual velocity vector for the plane? What would you do with these two?
You would
Add them. Okay? That's how I got that arrow in tan. I just put one onto the end of the other. Okay? Just add them together. So this is v sub p plus v sub w. Okay. Do we have an I component in v sub p? No. So it's just 56.57 I plus
negative.
yeah, we got a j component. -500 plus -443.43. So let's make that minus. All right, so now we finally have the velocity vector, the actual direction, horizontal and vertical components of the plane. Now the question was asking, find the speed. If we have time for direction, we'll do that, but let's at least find the speed. So how would you find the speed of this vector? What does that mean?
Find the magnitude.
Yeah, find the magnitude. And we're expecting it to be faster than 500 or slower?
slower.
It should be slowing down. The wind it's fighting the wind. Okay, what's the 56.57 squared? Good.
Plus
-43 squared. Good. And now just do that up. See what we got. All right, so we got, we can do it in a couple steps. 56.57 squared, 3200.16, plus, let's do 443.43 squared, 196,630.16. Yep, so I'm just going to add 3,200 to that, 0.16, and take the square root. So the speed of the plane is 447 miles per hour. Okay, and as far as the direction, let's just set up what you would do, but we're not gonna do that part. I'd say the easiest way to give the direction here is to find the angle right here, and then say it's at this angle east of south. Okay, so this is how you write your answer: theta degrees east of south. Any questions on what I mean by that? Like if this angle was 10, it would be 10 degrees to the east of due south. Okay. If you don't want to find that angle, you could find other angles. Find any angle you want as a reference point. Okay. Okay. Any questions on that one? All right, so homework for tonight in the packet, it's on 352. Okay, I want you to try 7 to 17 odd, 25, and on 7 to 17 odd, each question has 3 parts. Okay, but they're all related. I think the first part is find the angle. The second part is say if they're parallel, perpendicular, or neither. And I think the first part is find the dot product, find the angle, say if they're parallel, perpendicular, or neither. Okay.